In this, the 7th video on how to write a 3D space shooter game in Unity, I add rudimentary AI movement controls to our spaceships. I use rigid body physics, and I introduce you to a concept called a PID Controller, which is used to smooth the movement of the AI-controlled ships. So grab your favorite beverage, pull up a chair, and follow along as I teach you how to write a 3D space shooter game in Unity. So in order to add AI ship controls, I realized I need to do some refactoring of my movement controls again. I overlooked the fact that the AI controller needs to have a transform and a rigid body, which means it needs to be a game object. And so right now, if we look at our movement controls base, you'll see it's just implementing an interface. It doesn't derive from mono behavior, which means it is not a game object, can't be added as a component to a game object, and it can't have a transform or a rigid body. So what I need to do is I need to refactor this and derive from mono behavior. And I want to do the same thing for our weapon control base. Let Unity recompile. And this is going to break everything by the way that we're instantiating these. So there's going to be a little bit of refactoring to do here before I can actually implement our AI controls. All right, go back into Unity. Now the problem is we have this ship input manager that is instantiating our movement controls and our weapon controls. And you can see this warning here from Ryder that mono behavior instances must be instantiated with game object add component instead of new. I'm actually going to totally get rid of this, this ship input manager. And I'm also going to get rid of the other ship input control that we've got here, this guy here. So right now, the way I'd implemented it is we have ship movement input, which really is misnamed, but that had our ship input controls, and we had an input type, which we could select the type of input. I'm going to get rid of this. Actually, let me go into our prefab. And I'm going to get rid of that. All right, and I'm going to get rid of those scripts. So we don't want that anymore. And we don't want this anymore. And what we want to do instead is on our ship controller class, we want to have movement controls base, movement controls, and add a box group for this. So box group is an optional Odin parameter. Ship input control. So if you don't have Odin, you can get rid of this, you can get rid of this, and you can get rid of this and just have serialized field. If you try to include these attributes and you don't have Odin, you will get compilation errors. And I'm going to make this a fold out editor. Yes. And then I'm going to duplicate all of this. And I don't like this private keyword. Weapon controls base, weapon controls. Okay. So if we go back into the Unity editor and we look at our escort fighter, you'll see we've now got movement controls and weapon controls. So we're going to need prefabs now for those controls. They're going to be game objects that we can actually add into our scene. So let me collapse this. I'm going to create an empty, and we'll call this desktop movement controls. I will reset the transform, and I'm going to drag this desktop movement controls script onto there. I'm going to change that to 0.2. All right. And I'm going to create under prefabs a new folder. I'm going to call this ship controls. I'm going to drag that in there. And let's create another empty. Desktop weapon controls. Reset. And go back to our prefabs. Drag that into there. Now, I'm going to actually create another empty, because the player is always going to have one set of controls. I'm going to put this in a little group up here, and I'm going to call it player controls. I'm going to move this up to the top, and I'm going to drag these into there. All right, now on our escort fighter for movement controls, we'll add that, and you can see I've got the fold out editor. And then for the weapon controls, nice. There's really nothing to edit on there, but there may be later. Okay. Now, if I didn't break anything, I should still be able to move and shoot. All right, I can do all my movement, I can thrust, and I can still shoot. All right, so that was some necessary refactoring to get us to where we can start implementing AI controls. For the next step, we are going to create a new empty game object. I want to call this AI ship movement controls. Zero out that to world origin. And I'm going to create another one called AI ship weapon controls. And I'm going to go into my scripts, ship controls, create a C# script, AI ship movement controls. I'm going to drag them onto there. Create a new script, AI ship weapon controls. And I will drag that over there. And I want to create prefabs for them. So I will drag them into there. And I think before I get too much into that, there's some work I want to do. I want to make this ship controllable. I could apply these controls to our escort fighter here. But I think it'd be more fun to get this ship flying and chasing our fighter. And then, yeah, I just think that'd be more fun. So first of all, I'm going to reset his position. And I'm going to unpack this prefab. This prefab was dragged in from the third-party asset folder. I'm going to rename this escort fighter red. And under prefabs, I'm going to create a folder. I'm going to rename this one and call that escort fighter gray. And I'll drag this in here. Cool. And let's see. So we're going to want to make our engines actually do something. So if you remember on our escort fighter, the engines have a ship engine script. I also added some visual effects to it, to the thrusters. So the thruster has a trail renderer now, and it also has a point light. So first of all, I want to add the ship engine scripts to this guy. So go down to our scripts, ship controls, and drag ship engine onto there. And then they both want to have their thruster referenced. So we'll drag this guy's thruster, and we'll drag this guy's thruster. Cool. Let's go ahead and add the trail renderers. So we'll come up to here and we will copy component. And I'm going to come down to both of these guys. I'm going to add a trail renderer. And I'm going to paste component values. Nice. And then they both want to have a point light child. So I will copy component. Actually, do it one at a time. Paste as child. Paste as child. So now they both have point lights and they have trail renderers, and they will be turned on and off by the engine, ship engine script. Nice. The blasters. So we go look at our blasters here. They have a blaster script. So we will select both of these, go into the weapons folder and drag the blaster script. We're going to want to add muzzle to those. So expand this, copy, paste as child, paste as child, and then in our blaster script, we will drag the muzzle. Let me go ahead and apply all these prefab changes because we've made a lot. This guy's going to want a rigid body. And we don't want any gravity, but we do want mass, drag, and angular drag. So once again, override prefabs. And we need to add a ship controller script to this guy. Oh, these guys need to be children of this guy. And the reason is, well, definitely this one needs to be a child. But I think it makes sense for them both to be children. The reason these need to be children of the fighter is because the AI ship is going to need access to this guy's transform and rigid body. Well, definitely the transform. Let me drag that up there as a child. Nice. Now we will drag in the ship controller script. We want to drag in our AI movement control. Well, why is that now? Oh, we got to go edit these. All right. What else can we assign, though? The engines. So I'm going to lock this inspector. I'm going to grab both our engines, drag them into there, and grab both our blasters and drag them into there. Unlock that. Override our prefab. All right. We need to edit these guys' scripts. We'll do movement controls first. So these are not going to derive from mono behavior. They are going to derive from movement controls base. Implement missing members. Okay. Go ahead and get rid of these. So these guys are going to return a normalized value from -1 to 1 for each of these guys. So if you remember the way we implemented our controls, the ship controller is just expecting normalized values for these things, and then we will multiply that times whatever that ship data's pitch force, roll force, and yaw force is. And then the engines themselves handle the input and apply the thrust by doing add force instead of adding torque. So here we're adding torque. For thrust, we're adding force. Now this, what we're about to do is very advanced. Most people that develop this type of game don't try to control AI ships using rigid body physics. They don't add force and torque to the rigid body. They translate the rotation and position of the game object directly. But because of the way I design my controls, I need to control it through rigid body physics. And this is going to be a really interesting video today because we're going to get into some pretty complicated stuff, including something called a PID controller. A PID controller is a proportional integral derivative controller that's used to kind of apply easing when you want to get something to a particular state. So think of the cruise control in your car. You set your speed for 55. It will apply acceleration when it needs to get it up to 55, but then it kind of eases that acceleration off as you approach that target speed, and it tries to keep it at that speed smoothly. So you're not overshooting and then backing down and then overshooting, and then you're not oscillating beyond and behind the target. So we're going to do the same thing here, because if you imagine how we're applying our yaw and our pitch, we're basically saying I need to yaw to, in the clockwise direction to get towards a target. If I just apply torque to get me moving that direction, the angular momentum is going to carry us past that target. We're going to overshoot. And then it's going to have to apply torque in the opposite direction, and we're going to overshoot the other way, and it's going to oscillate back and forth and back and forth. What the PID controller will do is adjust the amount of torque that we're applying to get us to that target angle quickly, but keep us from oscillating back and forth. It'll smooth it out. It will basically apply easing to that. So I know it's complicated. It's kind of, I threw a lot of words at you at once, but it'll make sense when we actually apply this. In fact, I think what I'm going to do to start off with is I'm going to go ahead and copy and paste the code that I already wrote for a PID controller into here. And I'm going to actually move this to its own file. Okay. Add that to source control. And I need to import these missing references. So I'll really quickly go over what this is. I'm not going to go into great detail. If you're interested in PID controllers and how PID controllers work, I will put a link in the description. But essentially, we got our proportional, integral, and derivative gain. These are the three main parameters that are going to control how this adjusts our angle that we're trying to get to. So essentially, we're going to call this from our we're going to add a get yaw amount function in here. And that get yaw amount is going to call this PID controller's update. We're going to pass in time.delta time so that this can be smoothed out over the frame rate. We're going to tell it our current angle relative to the target, and we want to get that angle down to 0. So this will be our target angle. So if you think, we're facing a particular direction, our target is somewhere to the left or right of us. So we have an angle that we're relative to the tangent to that target is an angle. We want that to be 0. So we want to apply torque in a particular direction to get us toward that 0 angle facing the target. So there's a lot of math that's going on in here that's going to take these parameters that we specify, our proportional gain, our integral gain, and our derivative gain, and it's going to use that to recompute the result that we're going to give back and send to our ship controller. And we're going to clamp that to -1 and 1. So it's going to return the same kind of normalized -1 to 1 value that our ship controller is expecting from the movement controls. So I know that's confusing, and you don't have to understand this math. Just believe that I have put together a prototype where I tested this, and I have come up with values that I believe will work for these parameters to tune this controller to get us to our target angle quickly without having a lot of oscillation back and forth. So let's go ahead and write that code now. First of all, we are going to need some serialized fields, as always. One of the things we're going to specify in here is a target transform. And I'm going to go ahead and add these optional Odin attributes. If you don't have the Odin inspector and validator, do not include these attributes because you will get compilation errors when you try and build this. So basically, I'm going to box all these controls in a box called AI ship controls. And let's start with the yaw controls. Create another box group. I'm actually going to put this on a line like that. I'm going to get rid of that. Now I can just copy that, and I can say bool enable yaw. So what I'm going to do here, I want it to, in the inspector, be able to turn on and off the AI control for the different axes, so I can test them individually and make sure that yaw's working before I try to test pitch, before I try and test roll. I just want to make sure that one's not messing with the other. So I'll add another box group attribute, and I will add another field. This will be our PID controller for yaw. We're going to have a separate controller for each axis that we're going to smooth here. And I'm going to get rid of these private keywords because I don't like them. And I'm going to do the same thing for pitch. I think that's all the serialized fields I need. Now, for thrust, I know I'm going to need to know the distance from my target, because I think the way I'm going to apply thrust, I'm going to say if the target's more than a certain distance, thrust towards it. Initially, by the way, all I'm going to do is have the AI ship chase a target. So in future videos, we're going to create a finite state machine where the AI controller will have different states. There might be a patrol state, there might be a dogfight state, an evade state. I mean, who knows? I can envision many different states that I would want to have. But for now, we're just going to have a pursue state. It's just going to chase a target. So I'm going to add a little helper property here called distance to target. And all we're going to do is, if we have a target, We're going to use vector3.distance. We're going to subtract our position from the target's position. I need to create a variable for our transform and cache it. If we don't have a target, I'm just going to return 0. So let me add a private transform. I will add an await method where I will cache that transform. Okay, so that looks good. Now I want to add some public variables here. Normally I would make all my variables in here private, but I want to add some public ones because I want them to be visible in the inspector so I can see what's going on under the covers. It's a good way to when you're implementing something and it's got some complicated math and stuff and you want to make sure that things have the right values. A great way to do this is to make them public variables that will be visible in the inspector. So then you don't have to put in breakpoints or debug log statements or anything like that. You can just see them right in the inspector. So let's see. I'm going to add, actually let me move these guys down below my public properties. So let's see. Public variables here. I want a vector3. This is going to be our local direction. So we're going to do what's called an inverse. We'll take a quaternion.inverse operation that will basically, we want to get our local angle towards the target. So I'm going to have a variable for that. I'm going to have a float for our distance to target. And this is only for display purposes in the inspector because we're going to use this to actually do the work. And then I'm going to have a couple public variables, some floats for our pitch and our yaw. That's what we're going to send back to the ship controller. All right, so in our update method, we're going to want to compute. Well, first of all, we don't have a target. Let's just get out of here. We don't want to do anything if we do not have a target. Otherwise, we want to calculate our distance to target. This is just so I can see it in the inspector because the inspector won't show this. And I'm going to calculate our local direction. So this is going to be that quaternion.inverse. We're going to take our rotation. So we need to know the way we're facing. We're going to multiply that times our target position minus our transform position. So this is basically going to get the direction to the target, taking into account our rotation. So if I only did this, this would just give us the direction from our position to the target's position. This will give us the angle basically toward the target based on where we're facing. So all of that to create a method called getYawAmount. So if we don't have a target, or we did not enable yaw, return 0. Otherwise, yaw will be, we're going to do some math here. We're going to take an arc tangent. We're going to take that local direction we calculated and take the x-axis and the z-axis, and we're going to convert that from radians to degrees. And that will give us our angle towards the target in degrees. And now, if that is approximately 0, just go ahead and return 0 so we don't try and apply thrust if we're pretty much facing the target. Now, if we just return this, we're going to overshoot back and forth and have all kind of oscillation and stuff, and it's going to look horrible. So what we need to do is use our PID controller. So take our Yaw PID controller, and we're going to call the update method on it. Pass in time.delta time. Our current angle and our target angle. Remember, we want our target angle toward the target to be 0. And then up here, we'll add an expression body method and return get yaw amount. And while I'm in here, I will go ahead and create get pitch amount. Just going to return 0 for now. Get roll amount. I'm just going to return 0 for now. And get thrust amount. And you guessed it, I'm just going to return 0 for now. Expression body methods for all of these. Fix my spelling error. I think all of that looks good. And our AI weapon controller, we'll go ahead and say weapon controls base, implement missing members. Get rid of all these. And for now, expression body method, false. We will implement those later. Go back into the Unity editor. Did I have a typo? I'm always curious if people watching the video notice those mistakes when I make them. All right, so let me look at this. We will drag in this. We will drag in that. We will select the escort fighter ship data. Can minimize that. We've got our engines. Cool. All right, so on our movement controls, so I think for my proportional gain, I want 0.5, and I want 0.1 for the derivative gain. Minimum, maximum, those should all be fine. I'm going to disable pitch. But I think I should go ahead and put in my PID controller values. And for our target, I think what I'm going to do for my target, I could have it target my escort fighter. In fact, for the purpose of this demonstration, I'm going to disable the escort fighter in the asteroid field. I could have him target our fighter, but what I'm going to do is I'm going to add a cube, and I'm just going to have it oscillate back and forth, either on the X or Y or Z axis, maybe both, and just see if he torques to follow it. So yeah, that's what I'm going to do for our target. I'm going to create a 3D object cube. I'm going to call this target. Reset its transform and throw it out in front of the ship a little bit. And I want to write a script for this. I'm going to call it target mover. I'm going to put it under animation controls here. Create C# script target mover. That'll work. Select our target. Let Unity recompile. Drag that on there. And let's see. I'm going to have a couple serialized fields. I want to have a float for movement, horizontal movement, or horizontal range, and vertical range, and frequency. It's going to be doing a sine wave to make it move smoothly. I think that'll be fun. We're going to need our transform. Going to cache that. I can go ahead and cache it and start. I normally do it in awake, but it doesn't really matter. And in update, horizontal distance, do a sine, time dot time times frequency times our horizontal range, vert distance, I only need to calculate this once. And I'm going to create a vector 3 up here, which I'm going to call movement. In fact, I don't even need this variable. I'm going to say that movement dot x will equal that. Movement dot y will equal that. And I'll just initialize that to vector 3.0. And then we will take transform position, set it to our start position. Did I not save off my start position? Add another vector 3. Start position plus movement. Handy little useful script if you want to just have something move in a horizontal and or vertical direction at a certain frequency. Using a nice smooth sine wave. Back into the Unity editor. We will set that to 10, vertical range to 0 with a frequency of 1. Okay, so our target is moving back and forth. So our next test to see if I did everything right and did not break anything will be to assign that target to our AI ship controls. So to give this a test, I will drag our target onto the AI ship controls and hit play. And he's torquing the wrong way. I'm pretty sure I know exactly what's wrong there. Come back in here and hit play again. And the AI ship is torquing to follow our target, and that looks pretty smooth to me. Let's work on pitch. So back into here we go. We're going to want to look at our get pitch amount method. And once again, if we don't have a target, or if we didn't enable pitch, just return 0. So pitch is going to be a vector 3 dot angle and we're going to take vector 3 dot down not distance. Hey, is this football? And get the angle from our down axis to the local direction, that angle that we have toward our target. And we're going to subtract 90 degrees from it. It's just something we have to do because of the way things are oriented. And then we are going to use our pitch PID controller. And we will update time.delta time pitch and our desired pitch, which should be 0 toward the target. I think that all looks good. And we will, on our target, get rid of the horizontal range and just add the vertical range. And then in our escort fighter, we will disable yaw but enable pitch. And that looks pretty good. Let's enable yaw and go to our target and give it some horizontal range. And it is working. It's a little jerky. And that's something I can play around with the PID controller values and tune it a little bit. But I'm pretty pleased with that for now. So the next thing is to implement thrust. I'm going to go ahead and delete this target now. So let's go into our AI movement controls, and for thrust, I think it's going to be pretty simple. I don't want to go full-on thrust right away, so I'm going to use, and I'm not going to use a PID controller for this. I don't think I need to. I was wondering if I should add a public variable for thrust amount. So I'm going to use lerp. to go from our current thrust amount. I'm going to take our distance to target, and if it's greater than, I don't know, 100 units, then we want to lerp toward 1. Otherwise, we want to lerp toward 0. And we want to adjust that by time.delta time. So we're basically going from our current thrust amount to either 1 or 0, and then lerping that over time.delta time. And we're going to return that. Now I want to get him to chase our ship. So this is going to be fun. I think in order to really make this experience as fun as it can be, I want to put a camera behind the fighter so we can see his movements. So I'm going to come up here under camera setup. I've got a main camera. I've got a follow camera. I'm going to duplicate this. And I'm going to call this enemy ship follow camera. And then this guy is going to look at and follow the enemy ship. Now, in my camera manager, I've got a collection. Well, I thought I had a collection. Oh, it's a game manager. I've got a collection of virtual cameras. So I want to add this guy to the collection. I don't know why it's not letting me add a third item. There we go. All right, and if I understand, if I remember how I implemented this, is I'm basically taking the key press, taking key alpha, like 1 plus 0, 1 plus 2, 1 plus 3, and if it equals that index, I'm going to get that virtual camera from the collection. So I should now be able to select that camera by hitting 1 on the keypad, or 2 on the keypad. So I think 0 would be the cockpit camera, 1 would be the follow camera, and 2 should be this camera. I believe that's how I did it. We'll find out. Go into the tutorial in the editor. I will tell this guy to target the escort fighter. All right. I'm going to turn his shields off just so I can see a little bit better. Make this window a little bit bigger. Hit play. Did I not enable Yaw again? I did not. I was wondering why didn't he turn to follow me? He was going up and down, but not left and right. Switch cameras. All right, he's following me. Yep, he's chasing me. I want to implement roll now. It looks a little weird with him turning but not rolling. But that is sweet looking. Oh, I like that. Let me implement roll. I'm on a roll. I got to do it. So for roll, I think what I'm going to do is if it's turning, well, first of all, if there's no target, just return 0. All right, otherwise, return, I'm going to map that absolute value of the yaw amount. So if we're yawing left or right, doesn't matter which, if that's greater than, I don't know, 0.25, remember that's a normalized value from -1 to 1. So if we have at least 25% of our yaw, then I want to return yaw. But I think I need to reverse that. Otherwise, I'm going to return 0. So now he should kind of roll over while he's turning, and I think that would look more natural. Go back into the editor. Switch cameras after it comes up. So he is kind of rolling. It's hard to control my ship, though, from this view. Let me switch back to cockpit view just to get my ship under control. Oh, that's so cool. All right. So I'm going to go left and see if he doesn't roll to the left while he is. He's rolling and turning. Go back the other way. Yes. All right, so he is following. So we have rudimentary AI ship movement control implemented. I think in the next video, I might work on adding collision avoidance. So I'll re-enable the asteroids, and I'll have him chase me through the asteroid field and see if he doesn't avoid the asteroids. Well, that about wraps it up for this video. I hope you found it useful. And if you did, do me a favor and click that like and subscribe button. It really does help me to grow my channel, and I want to get this content in front of as many people as possible. And if you have any questions or suggestions about anything that you saw in this video, or anything in particular you'd like to see me cover in the future, do me a favor and drop a comment, and I'll do my best to get back to you as soon as I can. Thanks so much for watching, and good luck on your game development journey.